Good morning, children. Today we are going to have Circles Class 4 session. Welcome to the Circles Class 4. Today we are going to discuss some standard notations, position of a point with respect to a circle, related theorems and examples, definitions, secant, tangent, length of the tangent, power of a point, related theorems, examples and assignment. Before starting to our next session, let us revise what we have studied in our previous class. Children, we have studied how to write the equation of a circle when 3 points on the circle are given. Hope you all have done the exercise problems. Today we begin with the standard notations. These notations help us to discuss the coming problems of the exercise. As this is new, I would like to share the screen with both PPT and Blackboard. Let us explain some basic, very elementary things so that as it's a virtual class, you may feel more comfortable by having the brief discussion. If I have x square is written as x into x. Y square is equal to y into y. Z square is equal to z into z. In the same way, 2x is equal to x plus x. 2y is equal to y plus y. 2z is equal to z plus z. That means if it is with respect to, if it is power, if the number is in the power, we will multiply the terms. X square, x into x, y square, y into y, z square, z into z. 2x, our number now is the coefficient. When it is coefficient of x, we add the variable those many times. X plus x, 2y is y plus y, 2z is z plus z. At first, you know these notations, but my intention is to explain the notations in detail. Let us learn some notations that will be used in the rest of the session subsequently. The expression x square plus y square plus 2gx plus 2fy plus c is equal to 0 is denoted by s. We have seen the standard form of the circle as x minus h whole square plus y minus k whole square is equal to r square. We have also seen the general form of the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. That means general equation. And this general equation we are going to denote it by s. So here onwards, x square plus y square plus 2gx plus 2fy plus c will be denoted by capital S. Like we denote the point as P, some other letters, and the line as L. So S is equal to the same explanation what I have done on the blackboard. I have carried on PPT. Now x square can be written as x into x plus y square as y into y plus, now instead of 2gx I have taken 2x. G is constant, I have written in between, in the beginning, and in between I have taken in brackets 2x. 2fy I have written as f into 2y plus c. Now, x into x plus y into y is as it is. Look at the third term, children. Plus g into 2x is written as x plus x. And 2y is written as y plus y plus c. The expression xxi plus yyi plus g into x plus xi plus f into y plus yi plus c is denoted by si. That means you have two terms. Here in the first term x into x. In the second term y into y. In the third term x plus x. Plus in the fourth term you see it is y plus y. So whether it is product or sum, we have two variables x, y, y. Now I am substituting one variable as xi. In place of x I am taking xi. In place of y I am taking yi. So the expression xxi plus yyi plus g into x plus xi plus f into y plus yi plus c is denoted by si. Is denoted by si. So si is equal in the PowerPoint it is denoted as s in the one step better, but it is si. Si is equal to xxi plus yyi plus g into x plus xy plus f into y plus yi plus c. So this is our notation. I can substitute any value for I. I is equal to 1, then it comes S1. If I is equal to 2, it gives us S2. For I is equal to 1, what we have, children? Instead of Xi, we are going to have X1. Instead of Yi, we are going to have Y1. So G times X plus X1 plus F times Y plus Y1 plus C. Hope the notation is clear. Let us see some more notations. So for varying values of I, we get different notations. Now I am taking I is equal to 2. Then we get S2, which is X2 plus Y2 plus J times X plus X2 plus F times Y plus Y2 plus C. Now we have substituted only one X in the given terms. Now if we substitute different terms for first variable and second variable, we will get S12. That is, in the given term, in the given first term, we have 2x. For one x, I am substituting suffix 1, and for second x, I am substituting 2. Therefore, S12 is now x1, x2. In y also, the same notation carries. In subsequent terms also, the same notation carries. So S12, the suffix denotes what we are substituting for the variables. For two pairs of variables, x and y, in two terms, the first one is taken suffix 1 and the second term is taken suffix 2. Here only one suffix is denoted, means only one set of x is substituted. So S12 is x1, x2 plus y1, y2. The same goes in the remaining terms. The first term takes one suffix and the second term takes the suffix 2. In F term C, the suffix is 1 for the first term and for the second it is 2. If it is S13, x1, x3 plus y1, y3 plus g times x1 plus x3 plus f times y1 plus y3 plus c. Now, let us see what happens if we substitute the same suffixes. So, S12 is, for first term it is the suffix is 1 and the second suffix is 2. But here you observe in S11, both suffixes are same, 1. So, it takes the same suffix in the variables. X1 into X1 and Y1 into Y1 plus G times X1 plus X1 plus F times Y1 plus Y1 plus C. What is x1 into x1? x1 square. What is y1 into y1, children? y1 square. Now this time x1 plus x1. How many times x1? 2 times x1 and is multiplied with g gives us 2gx1. And y1 plus y1, 2 times y1 y1 when multiplied with f gives us 2f(y1) and plus c. So S11 is x1 square plus y1 square plus 2jx1 plus 2fy1 plus c. Please observe here it is double one and it is single one. Single one is in terms of x, y constant. So S1 is a linear equation in x and y. S1 is a linear equation in x and y. Whereas S11 is x1 is a number 4 constant. Y1 is a number like 5. When we multiply or when we simplify it together, it is a number. So S11 is a numerical value like 100, 96, 56 like that. Whereas S1 or S2 are the expressions in x and y. More precisely, linear expressions in x and y. And of course, S12 is also a number. X1 is a number, X2 is a number. Their product is also a number. So when you write the notations, you please have the geometrical interpretation of those numbers. Then you can have a good command over this exercise. I remind you all from the beginning of the chapter, I'm just going on repeating one sentence that coordinate geometry is the fusion of beautiful two branches of mathematics, both geometry and algebra. So when you write these expressions, it is algebraic interpretation of the concepts what we are going to learn. So when you talk that it is a linear equation in x and y, hence it represents a line. S12 is a constant, hence it represents a magnitude of the quantity or the object that we are going to study. So it's a quantity, like I have some rice in my hand. I have some 2 chalk pieces in my hand. It's a quantity. Whereas S1 is a line. Hope you all are clear. Now, this session is dedicated to the relative position of a point with respect to a circle, children. I would like to remind one important topic that we have discussed in our first year session. Given a straight line and a point, you are able to find out whether the given point lies on the straight line or not. You will substitute the given point in the equation of a line. If it satisfies, the point lies on the line. If it does not satisfy, the point does not satisfy on the line. So what I would like to tell an important thing is, there the straight line was unidimensional. So whether you can, if you substitute or doesn't, if it is satisfying or does not satisfy, it clearly tells us where will be the point. But circle is a two-dimensional closed figure. So there exists another condition. If I go in detail, if I have a circle on the plate, and the shading what I am doing is in the interior of the plane, and I denote the center of the circle. The center of the circle lies inside the circle. If I need to find the equation of the circle, I choose a point P on the circumference of the circle. Therefore, P is on the circle. All these points which are on the circumference on the circle. I can also choose some other points. Okay. All these points Q, R, S, T, U, V, W, X, Y are in the exterior plane of the circle. Therefore, given a point P, X, comma y. In the plane of the circle, there exist three positions for a point. So px comma y can be in three different positions. That means our circle divides the plane into three different parts. One is the interior of the circle and the points on the exterior of the circle, and the other is the points on the circumference of the circle. So, if a point is given px comma y may lie inside the circle, and px comma y may lie on the circle, and the point px comma y may lie outside the circle. So, the circle divides the complete plane into three different sets, three mutually disjoint sets. The first set, the collection of points which lie in the interior plane of the circle. And the second is the collection of all those points which lie on the circumference of the circle. And the third is the collection of all those points which lie in the exterior plane of the circle. So here comes the shading, which is interior part of the circle. And C is the center, which is inside the circle. And the point P is on the circumference of the circle. And Q is in the exterior plane of the circle. Let S is equal to 0 be a point in the plane. Let S is equal to 0 be a point in the plane. Let S is equal to 0 be a circle in the plane and P be a point in the same plane. Then P lies in the interior of the circle if and only if S11 is less than 0. And the same point lies on the circle if and only if S11 is equal to 0. And P lies outside the circle if and only if S11 is greater than 0. So this is a theorem that we are going to prove now. So P lies inside the circle, P lies on the circle, or P lies outside the circle are three geometric conditions that we have verified. Now let us see how we can prove it algebraically. So P lies inside the circle, P lies on the circle, P lies outside the circle. This is the geometrical interpretation. P is inside the circle, P is on the circle, and P is outside the circle. This is called the geometric notation. Let us derive the algebraic notation. How can we justify algebraically whether the given point lies inside the circle or not? Let us take the conditions one after the other. Let Px comma y be a point in the same plane of the circle S is equal to x square plus y square plus 2gx plus 2fy plus c equal to 0. And let us take the circle S is equal to 0 whose equation is denoted by S. And C be the center. Let C be the center and R be the radius. When C is the center, we know that it is minus D minus F. And when R is the radius, we know that the value of R is root G square plus F square minus C. Now, let us say the point is somewhere here inside the circle. Our condition is let Px comma y be a point inside the circle. Inside the circle. The first case is inside the circle. So point is P. Let us see how we can deduce the algebraic condition that S11 is less than 0. P lies inside the circle. P lies inside the circle if and only if. Under what condition the point is inside the circle? When the distance between these 2 points, the center of the circle and the point we have chosen, CP, is less than R. Because this distance is radius. So radius will be more than the distance CP, which means CP is less than R. CP is less than R. Now, I would like to stress on this topic more clearly. If I take a point P on the circumference of the circle, whose center is C, then the CP, the distance CP will be equal to radius. The distance CP will be equal to radius. So P lies. This is the second condition I am going to discuss. This is the first condition. So P lies on the circle. P lies on the circle. If and only if P lies on the circle, S is equal to 0 more clearly, where S is already given in the first case. If and only if CP is equal to R. In the first condition it is CP less than R. In the second condition it is CP is equal to R. What happens if the chosen point P is on the exterior plane of the circle? Let us take the circle with center C, where the point P is in the exterior plane of the circle, outside the circle. And this is any point, so this is radius. Case 3. If P lies in the exterior plane of the circle, if and only if, and that point will be outside the circle, followed one condition. What is that condition? The distance CP, this distance CP should be greater than the radius. Should be greater than the radius. Therefore, if our point lies inside the circle, the distance CP will be less than the radius. If the point P lies on the circle, then both the distances are equal. The distance between the center of the circle and the chosen point will be equal to the radius of the circle. If the chosen point P is in the exterior plane of the circle, then the distance CP is more than the radius, is greater than the radius. Therefore, CP is greater than the radius. In all these three cases, we are talking about the distance between the center of the circle and the chosen point P x, y. Since the distance formula is root x2 minus x1 whole square plus y2 minus y1 whole square, in order to avoid that root, I will square on both sides. When a square, it will be implies CP square is less than or equal to R square. CP square minus R square, I am bringing this R square to other side, is less than or equal to 0. It is strictly less than. So CP is less than R, CP square is less than R square. So CP square minus R square is less than 0 is the required condition for a point to be inside the circle. If the point P lies inside the circle, it satisfies the condition CP square minus R square less than 0. If CP square minus R square less than 0 is satisfied by a point, then point lies inside the circle. It is implies. In the same way, if CP is equal to R, squaring on both sides, CP square is equal to R square. Bringing R square to the left hand side, CP square minus R square is equal to 0. It's a required condition for the point P to lie on the circle. If point lies on the circle, CP square minus R square is equal to 0. If CP square minus R square is equal to 0, the point lies on the circle. It's vice versa. In the same way, we have CP greater than R, which means CP square is greater than R square. Implies CP square minus R square is greater than 0. So, CP square minus R square is less than 0. CP square minus R square is equal to 0. CP square minus R square is greater than 0. Therefore, the position of the point is all about one important condition, which is CP square minus R square is greater than 0, R is equal to 0, R less than 0 is a condition required for a point to be inside the circle, on the circle, or outside the circle. But what is CP square minus R square? That to be calculated. So, if CP square minus R square is less than 0, the point is inside. This point should be remembered. CP square minus R square is equal to 0. Point is on the circle. If CP square minus R square is greater than 0, the point is in the exterior plane of the circle. Is this clear, children? Now let us find what is CP square minus R square. Since you all know what is the circle, what is the center of the circle, S is equal to 0, what is the radius of the circle, and the point P is x comma y, let us find the distance CP square. X1 plus g whole square plus y1 plus f whole square is less than what is R square, children? G square plus f square minus c. And transposing g square and f square minus c terms with respect to addition to the left hand side. When we open the square x1 plus g whole square term, we get a g square term. Therefore, g square gets cancelled, and f square gets cancelled, and c also, and c remains. And what is the remaining term? X1 square plus y1 square plus 2gx1 plus 2fy1 and minus c when it is transposed with respect to addition onto the left hand side will become plus c. This complete notation is now S11. So S11 is less than 0. P lies in the interior plane of the circle. Now, our point is on the circle. When it will be on the circle? If and only if CP is equal to R. Squaring on both sides, CP square is equal to, sorry, this R square, children, by mistake it is animated as R suffix 2. And CP square, what is CP square again? Is the distance. X1 plus g whole square plus y1 plus f whole square is equal to what is R root over g square plus f square minus c square on both sides. And transpose the terms to the left hand side and then calculate. The remaining result is S11. Now P lies in the exterior plane of the circle. Where is the P now? In the exterior plane of the circle. When P lies in the exterior plane of the circle, CP is greater than R. R is only till here. Only this distance is called R. It is beyond this. So CP is greater than R, CP square is greater than R square. So x1 plus g whole square plus y1 plus f, sorry it is y1 plus f whole square is greater than g square plus f square minus c. Therefore, the simplification will come out to be S11 is greater than 0. Children, please ignore the sign here. It is typing a print. Okay, when we are giving for DTP, the problem in editing. Let us find the position of P with respect to the circle S is equal to 0. So far we have seen the theory. If H11 is less than 0, the point P x1, y1 lies inside the circle S is equal to 0. If H11 is equal to 0, the point lies on the circle. If H11 is greater than 0, the point lies in the exterior plane of the circle. Therefore, the value CP square minus R square is S11. CP square minus R square is now S11. CP square minus R square is now S11. So in all these cases, whether the point lies inside the circle or on the circle or outside the circle is exclusively on its value S11. If S11 greater than 0, the point lies outside the given circle. If S11 is equal to 0, the point lies on the circle. If S11 is less than 0, that is it come to be negative in minus, less than 0 in the sense negative value. S11 is a value. It is less than 0, means it is in negative, then the point lies in the exterior plane of the circle. Sorry, by S11 is less than 0 gives us the point is inside the circle. S11 is less than 0, then the point lies inside the circle. Now we have, let us find the position of the point with respect to the circle S is equal to 0. We have S as x square plus y square plus 6x plus 8y minus 96 is equal to 0 is the equation of the circle. And we also have a point. Now we have, with respect to this circle, we have to find the position of the point. What shall we do, children? First, write what is given. Given circle, given point. Denote the given circle as S and given point as x1, y1. And let us find the value of now S11. For that, we need to substitute both the values x and y. In place of x, let us substitute 1. In place of y, let us substitute 2. Then it is 1 square. Instead of x square, now we will write 1 square. Both x values are substituted because it is S11. So it is 1 square plus 2 square plus 6 into 1 plus 8 into 2, and the constant remains the same, minus 96. On simplification of which, it is minus 69. So S11 is less than 0. S11 is less than 0 in the sense the point lies in the interior plane of the circle. Is this clear, children? Assignment. We have the same kind of problems in our exercise 1B, first bit. Look at the position of the point with respect to the circle S is equal to 0, where the point is 3, 4, and the circle S is equal to x square plus y square minus 4x minus 6y minus 12 equal to 0. First, write the given point P as x1, y1 and the given circle as x. Simply substitute the point in the equation of the circle and denote it as S11. If S11 is less than 0, the point will be inside the circle. If it is equal to 0, then the point will be on the circle. If S11 greater than 0, the point will be in the exterior plane of the circle. These two problems are the homework problems. And we also have some other problems in the exercise. So please do the exercise and go through the example problems with which you will get the good presentation skills in the exam. Practicing more problems gives us good presentation skills. It helps us in avoiding simplification mistakes, and it helps us in getting fastness in the examination. Children, let us take a definition where we are very familiar. Definition: let P be a point on a given circle and Q be a neighboring point of P lying on the circle. So we have 2 points. One is P. Nearby P, there is also another point Q. And both the points P and Q are on the circumference of the circle. Join PQ. Now we need to join PQ. Then PQ is called secant. What is PQ? Secant. The limiting position of the line PQ, when Q tends to P along the circle, is called the tangent at P. Is called the tangent at P. So Q is approaching P now. Then the secant will become tangent. I just would like to show one animation. See, B and C are the 2 different points in the circle. C is approaching B, then the secant is becoming tangent. Now this is secant. In this position, if I stop the animation, What is this? It's a secant. B and C are 2 points on the circumference of the circle. Then what is the line BC for the circle? It's a secant. When C is approaching B through the circumference of the circle, not outside or not inside, on the circumference of the circle, C is moving on the circumference of the circle and is approaching B. See, it is closely approaching C. See, now it is no more, it will no more a secant, it will become tangent. It is secant when it is having see, when B approaches C along the circumference of the circle, then the secant become the tangent. It's a definition that we have in our textbook. So this is the animation made in GeoGebra. Let us go for our concept back again. So let P be a point on a given circle and Q be a neighboring point of P lying on the circle. Join P and Q, then line PQ is a secant. It's not the line joining P and Q. It's a line through P and Q. Therefore, it's a secant. Otherwise, it will be only join of PQ will be a third. It's not the line segment. It's a line. The limiting position of the line, that is secant PQ, when Q tends to be along the circle, is called the tangent at P. So, now we are going to have another definition, which is the length of the tangent. We got the term called tangent. Now let us see what is the length of the tangent. Length of the tangent. If P is any external point to the circle S is equal to 0 and T is any point where the tangent drawn from P to the circle S is equal to 0 is touching the circle, then PT is called length of the tangent. I repeat, let S is equal to be a circle. Let P x1 y1 be a point in the exterior plane of the circle. Let us draw a tangent from P to the circle. You can draw another tangent also, but to discuss this topic, I have taken only one tangent. And the tangent drawn from P to the circle S is equal to 0 is touching the circle. Tangent touches the circle only at a single point. And that point of contact is T here. Then the distance PT is called length of the tangent. The distance, see here, this distance PT. The distance between two stars. Now, what is length of the tangent? What is power? These are the two important topics that we are going to discuss. Power of a point. This is very important definition. Suppose we have S is equal to 0 as the equation of the circle and R is the radius. We have a circle whose center is C and radius is R. Let me take a point in the plane of a circle. Let us take a point. It can be anywhere in the plane of a circle. And then Cp squared minus R squared is defined as the power of P with respect. We stopped at a point, at a conclusion that Cp squared minus R squared is less than 0. Cp squared minus R squared is equal to 0. CP square minus point P x1 comma y1 with respect to the circle x is equal to 0. So the power is always defined for a point with respect to a circle. So what is the power? You will be given a circle, you will be given a point, and he will ask us to find out the power of the point P x1 y1 with respect to the circle s is equal to 0. Then we need to find out CP square minus r square. But do you need to calculate CP and then square, then find radius, then find r square, then CP square minus r square? Essentially not. Why? Because CP square minus r square value is h double 1. CP square minus r square value is h double 1. So it is find h double 1. Therefore, the power of the point with respect to s is equal to 0 is CP square minus r square, but this value is h double 1. Therefore, the power of the point with respect to the circle is h double 1. A point Px1 y1 lies in the interior of the circle or on the circle or in the exterior of the circle according as the power of P with respect to the circle is negative, 0 or positive. So, h double 1 is less than 0 implies the point P lies inside the circle. The point P lies inside the circle implies h double 1 is less than 0. 3 are mutually connected. With this, we have finished this important topic. And before concluding this session, to show you another important. See children, this is the application and it helps us mathematical students to understand algebraically, geometrically. Children will be of different types. Some understand equations well, numerals well, some understand geometry well, and some needs picture and some needs the combination of both. So for the different kinds of children, there are different explanations from the different teachers. Take the first circle, children. And the point P is on the circle. And what is the distance CA? Is radius R1 indicated with red color. And next is F. See the values. R1 is 1.77. And F is 1.64 because P is inside. See the blue dot? It is inside the circle, not on the circle. Like which value is more? Radius is more. When P2 is on the circle, H and F2 are same. See here, H 1.7 and it is also 1.7. So CP is equal to R. And when the point P is outside the circle, see the distance K and R. K is more, 5.97, where R is only 1.85. So this is a geometry application where you can have the values for the given radius and then whether these equations are justified or not can be checked. These are the advanced applications called GeoGebra. With this, I would like to finish today's class and please do the given homework so that we can understand the next class well. Have a great day, children. Thank you.